Hello, everyone. Thanks, Hao, for the introduction. I'm Aldeida from Monash University. Before I start, I would like to acknowledge the traditional owners of Naram, the Wurundjeri Wurrung people of the Kulin Nation. I pay my respects to their elders, past, present, and emerging, and to elders of all First Nation communities that are here present today. I recognize the significance of the Birarung to traditional owners as a life source and a meeting place and part of a 40,000-year tradition of building community and exchanging ideas on these unceded lands. And if you don't know, Birarung is the Yarra River that's just in front of us. So Andreas is not here today, and I'm not Andreas. Unfortunately, he couldn't make it, but he's well. He's tested negative, so now he's good. And I did reach out to him and ask, well, what did you want to talk about today? And he said that he wanted to talk about his ERC grant, which is in semantics of software systems. He has a video in his Twitter page, and also very generously he's made the proposal available for everyone. So I strongly recommend that you go and check his video and his proposal. But my talk today will be a bit different, although, as Ha mentioned, in a similar area. And I'd like to advocate today for the importance of software testing in this new age of software engineering. And I know you've heard a lot today about generative AI. Maybe you don't want to hear about it anymore. We just had a keynote today about it, just recently. But in a way or another, it will impact us, and I think it's important that we think about it, and it will impact the software testing field, both in terms of how do we test these systems, but also I think there's lots of opportunities there to use these systems for improving our testing approaches. There was an interesting survey by KPMG asking developers how do they use generative AI. And in the session yesterday, in this very session yesterday, the panel members were talking about how to completely automate the different steps of software development, which is a very interesting vision, and I think, yeah, wonderful. In industry, at the moment, generative AI is quite widely used in one form or another, in one level or another. And from this survey, these were the kind of things that software developers were doing with generative AI. From explaining the functionality of code to asking generative AI to simplify code, asking to explore alternative solutions, both in terms of code and architecture, asking which classes have the necessary functionality, class selection, writing code, improving consistency of code, generating unit tests, accelerating debugging, translating code from one language to another, and more other functionalities. So indeed, generative AI is already part of software development process and is helping software developers become more efficient. These generative AI-based systems are not just used by us as software engineers, but also they are finding real applications in the real world for safety and life-critical systems such as healthcare. And this is one of the examples, a recent example, where generative AI is being trialed to help doctors write notes, clinical notes. And this is a very time-consuming process. My sister is a doctor, and she tells me that's 50% of her time is about writing those notes. And as we know, our healthcare system is really facing shortage of doctors, so these systems can really help. But they open up quite a few questions around the ethics, the values, the reliability, the safety, and other issues that you probably have already heard in this conference. So yesterday, in this session, there were a few references to testing, and in particular, Mark Hammond was talking about how we can use testing as one of the many tools to safeguard these systems. Both, he was referring to the software engineering tasks, that is, if we use generative AI to repair our code, then testing can help us assess the repair and say, well, yes, this is truly, indeed, a correct repair, because often these systems can hallucinate and can give us the wrong answer. And so it can be quite time-consuming for people, for developers, to assess those solutions and choose the right from wrong. But testing can also be used for generative AI-based systems beyond our software engineering domain to test, for example, these AI-based systems used in healthcare. But these systems are quite different, and as you heard from the keynote today, quite different from the traditional software engineering systems. And they present new challenges. You've heard about many challenges that they present. And as I was thinking about this talk, and this was prepared in 5 hours, as Haas said, you know. Yesterday I was told, well, would you like to present? And this list of challenges was quite a big list of challenges, a long, very long list. And I had to distill it, and I had to shorten it, because it's only 10 minutes, and I cannot talk about all the possible challenges that are here. And so for me, the most two important challenges in this space, in the sense of testing generative AI-based systems, are two. And the first one, the first one is not a new challenge for testing, but I think it's even more, it will be a bigger challenge, is the oracle problem. When I talk about the oracle problem, what I mean is usually the oracle is the human that determines whether the software system exhibits a correct behavior or not. And it's been a long-standing challenge in software testing because it is a time-consuming task, and it takes a long time to label these test cases for correctness. But now, when it comes to generative AI systems, it's not anymore, well, correctness is one thing, but there's many other things that we need to care about. And we talked about, in previous talks as well, human values, ethics, fairness, and other aspects in terms of transparency, and other properties of these systems that are new for us. And in particular, when it comes to these human aspects, such as values, how can we build an oracle that can tell us whether a test case, whether a solution generated by generative AI is indeed fair, or is indeed unbiased, or adheres to our human values? And it was quite interesting today as well at the keynote, where Liming was talking about that humans, we need to have these bots that are checking whether the generative AI is doing the right thing. So these bots are the oracle. And how can these bots then know how can they learn about our human values, such as fairness, for example, or security, or other kind of values? We're doing some work in this space, but what I see in software testing, most of the work is focused around the fairness and how to test, but not around how to build these oracles that then can help the automation of software testing in this space. And the second challenge, and again, there's work in the community around this, is how do we know that we've tested enough? And how do we know that after testing, these systems are ready to be deployed and won't lead to any disasters or any life loss, or, for example, the doctor writing the wrong note for the patient? And the space that we've been working on in testing, we call it adequacy metrics. How good the test suite is, how well have I tested the system, what kind of new test cases do I need to generate, what are the strengths and weaknesses of the system. And mainly we've been focusing on coverage and diversity, but these metrics are not sufficient anymore, so we need to be thinking about new adequacy metrics that can guide us in terms of telling us, well, the system is good enough, is good, it's not just good, it's safe, it's reliable, it's unbiased, it's transparent, and all those other properties that we've been talking about in this conference. So these are the two challenges that I think in my mind, and I know probably if I had a bit more time, maybe my answer would have been different, but this is where I'm at. But I'd like to just briefly talk a bit about, so I'm talking about testing, and there's work going on in the community around using generative AI for testing. And this is quite a new and emerging area, and it's quite an interesting area. There's great potential there. We're not there yet. The state-of-the-art generative AI systems produce only 40% correct test cases compared to 100% when we are using search-based software testing, and up to 47% coverage, while we are achieving 100% with search-based software testing. Well, they are useful tools to use generative AI because the argument is that they produce human-readable tests, whereas with search-based software testing, readability may not always be there. So it's an interesting area to explore, and lots of potential there as well. I would like to finish with my prediction for the future. And as the very wise Niels Bohr said, it is difficult to make predictions, especially about the future. And I like this quote because it also relates to the importance of testing. And these generative AI systems have been trained on past data, and they're not very good, to predict things about the future. And this is another argument on why we need testing, because with testing we can generate these unseen cases and improve and safeguard these systems even more. So thank you for your attention.